Hi, welcome to part C, question 10. Part C, question 10. So in this question, we have quite a strange expression of trigonometry, but we need to change it in this form. And you can see that we have a cos 2x minus alpha. Now this is a double angle, but what we have here is a single angle. So there is some manipulation we are going to make on the left hand side. So we need to create a double angle. Alright, let us see what will happen when I expand this. So we just need to equate 3 sine squared x plus root 3 then sine x plus x plus 4 cos squared x to be equal to a plus b cos of 2x minus alpha. So here we are. Now, of course, when you see sine and the cos, that is very easy to create a double angle. We shall have to expand this, but now there is some work to do here. We need to have double angle on the left hand side. The hint is from here. You can see that the double angle is needed because we shall be getting cos 2x, we shall be getting sine 2x, so we need to create a cos 2x and sine 2x here. But the sine 2x can be got from here. Remember that sine of 2x is equal to twice sine x cos x, implying that this one alone can be converted to a double angle. How? Because the sine x cos x is a half of, if I divide it by 2, and even here I divide it by 2, it means that sine x cos x is a half of sine 2x. So this can as well be written as 3 sine squared x plus root 3 over 2 then sine 2x plus 4 cos squared x. Okay, equaling to the right hand side. We shall expand it later, but let us first work on this left hand side so that we are sure we have double angle. Now from that, now what about this one here? Now whenever I say sine squared and cos squared, to get a double angle, think about the cos squared, sorry, the cos 2x. We know that cos 2x is the same as cos squared x minus sine squared x, but at the same time it is the same as 2 cos squared x minus 1. It is the same as 1 minus 2 sine squared x. What does it mean? That we can make cos squared x the subject. So the cos squared x can be written as, we take 1 the other side, which is 1 plus cos 2x then divided by 2, and sine squared x, if we make sine squared the subject here, we bring it on the left, then we take this one on the right. It will be 1 minus cos 2x divided by 2. So these are important identities. So we are going to use this to substitute for sine squared and cos squared. So we shall say that this is 3. Now when I have sine squared, I will take 1 minus cos 2x divided by 2 plus root 3 over 2 sin 2x, then plus 4, then this will be 1 plus cos 2x divided by 2. Now the area of this is equal to the right hand side. Now since I have now got the double angle, just a matter of simplifying, then I will also expand the other one. So let us remove the bracket from here. If we remove this bracket, we shall get 3 over 2 minus 3 over 2 cos 2x from this bracket. 3 is multiplied here and here, 3 is divided here and here, then plus root 3 over 2 sin 2x, then plus 4 over 2, this 2 cancels with that, so we shall get 2 plus 2 cos 2x. See, I'm still cleaning the left hand side before I expand this and I equate the coefficients. So now we can see that we have a constant, and here we had a constant here. So the constants we have a 3 over 2 plus 2 now let us see, we have the cos 2x, meaning okay, let me first deal with this sign. So plus root 3 over 2 sin 2x. Now I'm correcting like terms. Now cos 2x then you shall be left with 2 here minus 3 over 2. So simplifying further, let me clear and I make more space. So we have 3 over 2 plus 2, this is 1.5, which is 3.5. Then plus root 3 over 2 sin 2x, then plus, now this is going to be 2 minus 3 over 2, which is a half, cos 2x equaling to a plus b cos of 2x minus alpha. Now I have double angle, and now you can see this a here is going to be the constant, I hope. Then we need to have an expansion of this one here. So let us see what we get when we expand this b cos 2x minus, we shall be getting a plus, now the b on cos 2x cos alpha, and the plus b sin 2x sin alpha. This is equal to the left hand side, 7 over 2 plus root 3 over 2 sine 2x, then plus a half cos 2x. So from here what we need is now to compare. We just have to compare. When you look at this, a is equal to 7 over 2, the constants. Then the coefficients of sine 2x, that is b sine alpha. So b sine alpha is going to be equal to the coefficient here, which is root 3 over 2. Then the coefficient of cos 2x, we have b cos alpha equaling to a half. So let us now find out what we need. Of course we have got our a, we need to get the b, we need to find alpha. So to get b, I'll need to square both sides and I add, and when I do that I'll get b squared into sine squared alpha plus cos squared alpha, giving us 3 over 4 plus 1 over 4. So b squared is going to be equal to 4 over 4, which is 1. So b is equal to the square root of 1, which is plus or minus 1, and we shall take b to be 1. So far what we have got is our a. This a is 7 by 2. We have got the b, which is 1. Now we need to find the alpha. We find the alpha by dividing. So we shall divide these two equations, and we'll be having a tan. So this by this, we shall get tan alpha equaling to root 3 over 2 divided by a half, or times 2, and tan alpha is going to be equal to root 3. So our alpha will be the tan inverse of root 3, and this is going to be 60 from the calculator. So this can be expressed in a form. Thereof this, we'll have our final answer as 7 over 2 plus cos, because the other one is a 1, the coefficient here is a 1, then 2x minus 60 degrees as the answer. So thank you for watching. I am Teacher Ginger Isaac. So that is how we do this number. It required some time. You have to first recall the double angle identities, and you need to manipulate them so that you get rid of the sine squared, the cos squared in that form. So you have to find a, you have to find the b. So there were 3 unknowns you have to find, and which we have done successfully. So alpha I have taken it to be the acute angle because you don't have the range. Remember, tan is positive, it can be in the first or in the third quadrant. So you don't have a range, let us take the acute angle.